We are going to begin this topic by considering the moment of a force. But before we go into the moment of a force, I would like to introduce to you what equilibrium of forces mean. Actually, in the real sense, everything is geared towards attaining a state of equilibrium. An equilibrium is actually a state in which a particular body is stable. In other words, it is called a state of stability. So bringing it down or streamlining it down to what we have for today's class. Equilibrium of forces is a state where the forces acting on a particular body balances out. That is, they are stable. Okay, so talking about the equilibrium of forces, we will begin by considering the moment of a force. And by definition, moment of a force about a point is actually the product of the force and perpendicular distance of its line of action from that particular point. So moment of a force is mathematically represented as m is equal to F times the perpendicular distance. It is measured in Newton meter because force is measured in newtons and perpendicular distance is measured in meters. So force times meters is equal to Newton meters, and that is the unit for the moment of the force. Now there is a principle that actually guides the moment of a force, putting into consideration the forces that act on the body, and such principle is called the principle of the equilibrium of forces. And it states that when a body is in equilibrium, the sum of anti-clockwise moments of that body about a point is equal to the sum of the clockwise moments about that same point. So this principle is also, or can also be stated as, the sum of forces in one direction is equal to the sum of forces in the opposite direction. So this is the principle that guides the equilibrium of forces, that is the principle of moment of a force. Is that okay? So let us consider an example to illustrate what we have. The question is, a body of mass 58 kg is suspended at 20 centimeter mark of a uniform meter rule. I would like you to take note of this uniform meter rule. I'll tell you what it means in a short while. So the meter rule is adjusted to a point until it settles horizontally at 40 centimeter mark. Determine the mass of the meter rule. This is the question that we are asked to find. Now we have an horizontal meter rule of this form. So this is the horizontal meter rule. And the meter rule has calibration from 0 to 100 centimeters. So the question states that the meter rule is uniform, and then the body of this mass 58 kg is suspended at the 20 centimeter mark. So from 0 to the point where the body is suspended, so we have, this is the body of mass 58 kg, and then it is suspended from this point to this point is equal to 20 centimeters. And then we said the meter rule is uniform. Because they said the meter rule is uniform, so the center of gravity is at the midpoint. The center of gravity, that is the point where the weight of the body is assumed to be concentrated. Is that okay? So it is at the 50 centimeter mark. Right. So we also told that the meter rule is adjusted so that this meter rule can balance, because of course when a mass of 58 kg is applied at this point, you realize that the meter rule tends to tilt this way depending on the direction. Okay, so the meter rule is going to tend to tilt the other way around, so as to make this meter rule to balance on the knife edge. So let's say the knife edge is at a point here. Remember, I said the meter rule is uniform. That is, the center of gravity is at the midpoint. Okay, so we're told that the meter rule is adjusted on a point until it settles horizontally at the 40 centimeter mark. So let's call this the 40 centimeters mark. Okay, from this point to this other point is 40 centimeters. All right, now determine the mass of the meter rule. Actually, a mass, because we're told that the center of gravity is at the midpoint, that is, the meter rule is uniform, so we can assume we can angle the mass, another mass, so as to balance the effect of these 58 kg on the other side of the balance, or on the other side of the meter rule. Okay, we need to look for an equivalent mass that will balance the mass of the object that has been hung on the other side. Okay, so this is the mass we are looking for. You agree with me that at this point, the distance from this point to this point is going to be 10 centimeters, such that from here to here is 50 centimeters, which is half of the length of the meter rule. And why is this so? It is because we're told that the meter rule is uniform. We have a uniform meter rule. Okay, now since this is what we have, we can decide to bring up the relationship. Remember, we said that the moment of a force, there is a principle that backs it up, and the principle states that the sum of the clockwise moment is equal to the sum of the anti-clockwise moments. That is, in another word, we can say that the forces acting in one direction must be equal to the force acting in the other direction. So from this meter rule over here, we can have the expression to be this mass, the sum of clockwise. This is clockwise and this is anti-clockwise. Okay, so the sum of clockwise moment is equal to sum of anti-clockwise moment. So clockwise is equal to anti-clockwise. So we can, since the clockwise moves this way, so this mass m times the distance from where this mass is to where the knife edge is, okay, which is 10 centimeters. So we have times 10 is equal to the anti-clockwise. So the distance, the mass, which is 58, times the distance from where this mass is to where the knife edge is. Okay, so that is the anti-clockwise moment. So we have, if from here to here is 40 and from here to here is 20, therefore from this point to this point will definitely be equal to 40 minus 20. All right, so this will give us 20 centimeter as well, such that if you add 20 to 20, it's going to give us this 40 that we have over here. So now that we know the distance to be equal to 20, so 10m is equal to 58 times 20 is going to give us 1160. So if we divide through by 10, m is equal to 116 gram. So for this meter rule to be able to balance, for it to attain a state of equilibrium, a mass of 116 gram must be attached to the other end of the meter rule. Okay, let us just draw another, this is m, let us draw another meter rule so as to illustrate this. So we have something like this. We have this is the meter rule. Okay, this is the meter rule, and this is 0, this is 100 centimeters. We said the mass 58, this is 58 gram. So this is the knife edge. A mass 116 gram has to be attached to the other end of the meter rule so that this meter rule can balance, or so that it can attain the state of equilibrium. So this is where we'll end the class on the concept of moment of forces. In the next class, we are going to talk about the moment of a couple. So see you in our next class.